Okay, so in this tutorial we're going to cover adding some advanced features to the tessellated displace material that we created in the previous tutorial, which I have linked in the description of this video. In that tutorial we basically covered creating a texture packed texture file to import into the editor and then creating a tessellated displace material for use with that packed texture, which is what you see here. So you can either pause the video here and recreate these nodes the way you see them here if you're comfortable with that, or you can go back and watch that video and then watch this one to add the advanced functionality to it. So the first thing we're going to do is delete this tessellation multiplier. And we're going to create an entirely new tessellation multiplier node tree. So the first thing we want to do is create a static switch parameter. So you want to right click and then just type in switch and then make sure you do static switch parameter. This will allow us to change this static switch via the material instance that we create later. So we want to give this a name, and we're going to call this one use advanced resolution method. And I have to make sure that every word is capitalized or it bothers me later, and then get rid of this none, obviously. And make sure it's in the correct group. So we're using main for all of the non-texture nodes. So the next thing that we want to create is a one vector. Now you can do this by holding one and then clicking on the grid, and then we want to convert it into a parameter. So you right click it, click on convert to parameter, put it in the appropriate group. Once again, we're going to call this one tessellation resolution. And we're going to plug that into the false output of this static switch parameter that we created before. And we're going to take this tessellation multiplier and plug this into the static switch parameter. So once our node tree is done, it'll be set up. So the next thing we want to do is create a linear interpolate. So to do that, you hold L and then click on the grid. We're going to put the true value of that static switch parameter into that. And then we want to create two more one vectors, but since we already have this one created, we can select it, move our cursor to where we want those two nodes to show up, and then hit Control W. And it will create duplicates of it wherever we have the cursor. So you want to plug the A value into the top node and the B value into the bottom node. Now we're going to rename both of these nodes. The top node is going to be called near resolution, and the bottom is going to be called far resolution. Now we are going to need something for this alpha to plug into, so we're going to create a clamp. So once again, right click and then search for a clamp. And select the clamp that's under the math branch. So take the alpha from your lerp, put it into this clamp. Now we're going to create a divide node. Plug the main node of your clamp into the divide. And we're going to create two more one vectors. So once again, you can select one that you had created previously, and then hold Control, hit W, hold Control, hit W, and then you have two of them. So we're going to take the B value of the divide, plug it into the first node. And we're going to create a subtract. Take the A value and put it into the subtract node, and then take the B value of that subtract and put it into this second one vector that we duplicated. So we need to rename these one vectors. So the first one on the right is going to be called near distance. And the one on the left is going to be called far distance. And I just realized I did not capitalize resolution here, which is going to bug me, so I'm going to change that. Okay, now we are going to create a distance node. So right click and search distance under utilities. So now that we have that created, we need two nodes for those A and B outputs to plug into. So we're going to find camera position. So camera position WS. And then we are going to find actor position WS. So now that we have both of those created, you want to put the B into the actor position and the A of this distance node into the camera position. So this is going to allow to figure out the math from the camera position, which is the player's view, to the actor position, which is the surface that the tessellated material is applied to, and then come up with the distance between those. So this near distance is the distance at which the resolution starts to drop off. So for this, I'm going to set a default value of 700. And for the far distance, I'm going to set a value of 1,000. This is in UE4 units, centimeters. So this should be good for just about any setup, and the player should know what's going on with this distance setup, and it should still be pretty performant. So this is the entire node tree for the advanced tessellation multiplier. So it'll actually fade out based on view distance from the surface. I just like to make sure it's all organized and condensed as much as possible. So now we're going to select all of those nodes, right-click, and then do a comment, which will surround all those nodes in a comment box. And we can call this one tessellation multiplier. So that way we know what these nodes control. Another thing we can go in and do is near resolution and far resolution. So your near resolution is going to be the highest resolution is going to be closer to the screen. So I usually like to use a value of 2. And then obviously the far resolution is going to be 0 because it should fade out to no tessellation whatsoever. So now that we have that set up, you want to hit save because it's always a good idea to save your materials as you're going along so you don't lose any changes that may have taken a while to do, or forget where you left off or anything like that. So now that we've finished this tessellation multiplier chunk, and as soon as this material is done saving, we will move on to the next part, which is going to be the height fade. So what the height fade will do is it'll actually fade out the height of your displacement based on view distance, exactly like this does. It's the exact same node tree, but we are multiplying the displacement by the node tree rather than plugging it straight into the tessellation multiplier. So you could just add a multiply here and then plug the multiply, or multiply this multiply by this value here, which will keep the height fade in sync with your resolution fade, which would be the quickest way to do it. It's less instructions and all that, but for some reason, if you want more control over the height fade, like you want it to fade out before the resolution does or after the resolution does for whatever reason, then it's a good idea to create a separate node tree just for that. So we're going to select this entire comment box and the nodes it contains and do a Control W once more, which will duplicate it. Put this one up here. And we can rename this to height fade. And we obviously want to rename all these nodes to correspond with being height rather than the tessellation multiplier that it was before we duplicated it. So use height fade for this static switch parameter. This should actually not be a parameter. We can just set it to a 1 vector. So I held 1 and then clicked on the grid, and that created this 1 vector and give it a value of 1. So if you have this use height fade set to false, then it'll keep it at a value of 1, which is multiplying whatever height value you have in your displacement height by a value of 1. So it'll always stay to wherever you have this set to, regardless of distance. So the next thing we want to do is change near resolution to near height. And once again, these will do the same thing that your near resolution, far resolution does. It'll give it the near distance in units from the camera to start fading out, and the far distance will be the farthest distance where it's faded out completely. So we'll call this one far height. And then we want to do near height distance and far height distance. So these two nodes are actually going to control the distance from the actor and the camera. These two nodes control the value. So the near height value is going to be 2 at a distance of 700, and the far height value is going to be 0, which means it'll be completely flat at a distance of 1,000 units. So between 700 and 1,000 is where it's fading from full height to 0 height. So now all this is set up, we can multiply this displacement by that node tree. So if you hold M and then right click anywhere, or left click anywhere, and then take this world displacement, plug it into that multiply, take the A output of that multiply, plug it into this multiply, and then take the B value of that multiply and plug it into this static switch parameter, you now have the height fade set up. So once again, we want to save after we create that new node tree. Okay. Now that this is done saving, we are going to go in and add the advanced rotation and tiling node tree, which will be the last one of this tutorial, and then we can go in and see what everything controls and how it all looks in the editor. So the first thing we want to do is create a custom rotator. Which will give you a node that looks like this. Now, since we already have the tiling set up here, we can just take all the nodes from this divide, and we're going to plug them in here. So in order to do that, you hold Control, and then you click on this, and it'll take all the inputs that are going into that and put them wherever you place them. So put them into here, and then we can delete these nodes. Then we can expand this tiling comment box to about here, which is going to encompass all the new nodes that we're going to create. So the first thing we want to create is going to be a one vector. So once again, we can do a Control W on one that we've created before because it is going to be parameterized. So we were going to call this one rotation. And we want to give it a value of 0 by default. That means there is no rotation applied to it. And we're going to take the rotation angle and plug it into there. Now we want to create a 2 vector, and the 2 vector is going to have a value of 0.5 and then minus 0.5. What this will do is give it a rotation value between 0 and 1. It just makes rotation much easier. So rotation center is going to be zeroed out. So plug this rotation center into that 2 vector that we created, and this does not need to be parameterized because there's no need to adjust it in the material instance. The next thing we want to do is create another static switch parameter. So we're just going to duplicate this one, select it, Control W, put the UVs into the static switch parameter, and we're going to call this use relative tiling. And this is going to plug into another static switch parameter. So we're going to create another one. Call this one use horizontal vertical. Now the reason I put horizontal first and vertical second is because true is going to be horizontal and false is going to be vertical. So it just gives you a little bit better correlation when you're editing in the material instance. At least for me it does. But you can name it however you like. So take the true vector of the use relative tiling, plug it into this use horizontal vertical static switch parameter. Now we're going to create a divide. Take the false from that use relative tiling static switch and plug it into the divide. Now we're going to create a texture chord. So you can just type in chord, and then we're going to take the A value and plug it into this texture coordinate. So the texture coordinate basically controls the texture set tiling. So a value of 1 to 1, it's going to be the exact texture size that you import. So if it's a 4K texture, it's going to be 4096 by 4096. If you set this to 2 by 2, then it's going to be double its density, so it'll be half its size. So anyway, so we will take this use horizontal vertical and duplicate it again. And we're going to call this one use X or Y. This is going to switch between the X and the Y axis for the vertical alignment. So I'll take the true and plug it into that. Now we are going to create 3 masks. So right click and do mask, component mask under math. And we are going to duplicate this twice. Control W while having it highlighted. Spread them out a little bit. So the first one, you want to make sure that you only have G and B selected in the expression component mask details over here. For the second one, you want to have R and B selected. Make sure you uncheck G. You should only have 2 values selected for each of these. And then the last one is going to stay as RG. So we are going to take the true value of this useXY, plug it into the GB. False is going to go into RB. And then we're going to take the false value of this use horizontal and vertical and put it into the mask RG. Then we're going to create another divide, so you can select this one, hit Control W. And then all 3 of these masks are going to plug into this. And then we're going to create a world position node. And we're going to take the A output of the divide and plug it into here. Now we're going to create another 1 vector, so we can duplicate this rotation. Once again, select it, Control W. And we're going to take this divide, plug it into here. The B output of the divide is going to go into here. And the B output of this divide is going to go into here. And we're going to rename this to tiling. And we should give it a default value of 1. Now, when you switch between relative tiling and the standard tiling, you're going to go between using actual texture units to using multipliers of the texture coordinate. So if you're not using relative tiling, you're going to use like 1, and then 2 would make it twice as small. It would double the tiling. But if you're using relative tiling, then you would use values like 512, 256, 496, texture units. So yeah, so this is the setup for the advanced tiling and rotation. So now that all of that is set up, you obviously want to make sure that you save it. And as soon as it's done saving, we can get this material window out of the way, and I can show you what it actually looks like in the editor. So this is the material in the editor. This is the material instance based off of that material that we just updated. So as you can see, all of the static switch parameters are here. The default tiling is here. So if I scale this down to 1, to 2, 0.5, as you can see, it scales based on those values. Texture resolution is obviously how densely packed the tessellation is. As you can see, since we do not have use advanced resolution method enabled, there is no real fade out for the tessellation. It's just always at full resolution. So the first thing we'll go over is the advanced resolution method. So if I enable this, your materials may need to compile when you first go through and check these static switches, because it's basically loading in the new set of nodes that it didn't know was there before. But once you do it the first time, it shouldn't have to recompile. So once this is done compiling down here in the corner, I can show you exactly how this works. So right now it has a fairly high value, which is a start value of 700 and an end value of 1000. So as you can see, it starts to fade out when I get this far away from it. Now that tessellation that you see is just the tessellation of the mesh itself. So if I go back in, you can see the GPU tessellation fade back in. So what I'm going to do now is go to a lower near and far value. So I'm going to set the near distance to 150. and then the far distance to 300. So you can see how the effect works much better. So as you can see, it fades out and your detail drops quite a bit. Now, one thing that you'll notice is even though the tessellation is fading out, the height map is still being applied. So you can see that the surface is still kind of raised, but it's raised based on the tessellation that we have in the mesh itself. So this is where the height fade comes in. So once again, it's going to have to compile the part of the material that it didn't know was there before, because we just selected height fade, which enabled that other node tree that we created for the height fade. So once it's done with that, I can show you exactly what the height fade does. So over here in the material instance, once again, we have the default values that we set up of 700 and 1000. So for near height distance and far height distance, I'm going to change them to the same values as the tessellation resolution fade out. So we're going to do 300 for far and 150 for near. So now if you watch the surface carefully, you can see that it fades to flat as we zoom out. It's probably more noticeable on the sphere here. As you can see, the surface goes from displaced to flat. Now, what this allows you to do is if you have, say you're using these grids for a floor and you have, 20 of them laid out, you have this mesh duplicated 20 times. I believe this mesh is around 512 polygons. So if you want to lower it down to a single plane that's only 2 polygons, but you have the height values still there, you'll get separation along the edges of the meshes. So if you have 2 of these next to each other, and it, you have the tessellation fade out, but the height value is still there, and then you go down to a 2 poly mesh, it's going to have 2 polys trying to meet up against these 24 poly edges, or 24 squares. So it's going to create a gap, which you obviously do not want in the scene. So what this allows you to do is it'll actually fade out the height. So when you switch over to a lower resolution mesh, a mesh with 2 polygons, both surfaces will be flat when they meet up, and you can conserve your poly counts, and it'll just be more performant and give you more detail up close where you need it. And it's just a much better method for achieving a high level of detail without sacrificing too much performance. So the next thing that we're going to go over, now that we have that height fade set up, is we are going to go and enable relative tiling. So before I do that, I'm going to show you what it looks like without relative tiling. So if you move the mesh without relative tiling enabled in any direction, you can see that the textures just move with it. So this is bad if you have like custom scaling on there and you want to duplicate the mesh over and over, and it won't line up and it's just going to look weird, especially if you want to do like a something where the mesh is moving at runtime and you want to have it line up with other objects. So to fix this, we want to enable use relative tiling. So with that enabled, once again, it's going to recompile the shaders because it's adding another node tree into the material. So now that this is enabled, once it's done compiling here. Okay, so now this is enabled, you're going to use a different method for tiling. So rather than using lower values like 1, 2 that are going to be multiples of the original coordinates, you want to use texture values, or texture size values. So 512, 1024, 256, etc. So we're going to use 512 for this example, which should be comparable to the value of 1 that we had before. So now that we have relative tiling enabled, if I move the mesh around, you can see that the textures stay in the same place. Now you'll see that the height fades in and out based on the distance from the camera of the mesh, even though the texture is staying in the same place. So you can come up with some cool effects using that. But yeah, so now we have relative tiling enabled. So now that we have relative tiling enabled, it's only set up to work for horizontal surfaces, so ceilings and floors. But if we wanted to, turn this mesh, sideways and create a wall with it, you'll see that it starts to stretch out because it's tiling it relatively to the world in the X and Y axis. So in order to fix that, It actually shows up a little bit better on this sphere. So as you can see, the top of the sphere is, it's tiling as it should because it's facing, it's on a horizontal plane, whereas the sides are getting all warped and everything because it's basically just shell stacking the textures. So if we want to fix that, say we want to use this on a wall, for example, we can say we duplicate this plane, we turn it 90 degrees sideways, and move it over here. So now let's say we want to use this material for a wall. So we would want to check use horizontal vertical. So by default it's horizontal, which is false, and then true would be vertical. So once we enable that, once again it's going to compile the shaders. It's adding another branch of nodes into the material. So now that we've enabled that vertical checkbox, you'll notice that we have a new parameter which is exposed, which is use X or Y. So by default, it's going to be set to X. So if you try to move it this way, you can see that it's staying in world position. But if you rotate this mesh, as you can see, it's when it goes into the Y plane, it is not moving. So in order to fix that, we would check this box, use X or Y. If we check it, it's going to flip over to the Y axis. Once again, it's got to compile the shaders. So it's adding in a new node tree. So now, as you can see, if we move it this way, it is world aligned in the y-axis. So rotate it back, and if we uncheck it now, it won't have to compile shaders, since it's already done so. And you can see how it works on this sphere as well. So as you can see, this way it's not tiling, or it's not aligning to world, but this way it is. So then we'll go back and uncheck horizontal vertical. And this is what the final result looks like. Now, just one more thing I'll go over is to show you why this height fade is an important feature, is if you duplicate this by holding Alt and then just dragging in any direction, and just making sure that these are lined up properly. So as you can see, the height fade is it's down on that mesh, and then it's up on this one, and now it's down on this one as well. So if you watch it in wireframe mode, you can see exactly what's happening. So say, for example, you have these two grids. This is the way you're creating your floor. You have this grid mesh and then this grid mesh, and you're just duplicating them over and over, and you have, I don't know, 20 in a row. And you want to lower your grid mesh resolution from this tessellated version down to a single plane, which would be a flat 2-poly version. You do not want to have any height information along the edges where they meet, or else where they meet, like right along here, you're going to be able to see under the other mesh because the edges will not line up because the poly counts are different. So if both edges are flat, then you will not have that problem. As you can see, it's a very subtle effect, but when you're on top of it and you're looking down on it, you can see that the detail is there, and then when you pull back, it's not as obvious. So now we're going to cover the rotation that we added in as well. So rotation, you obviously have to check it to enable it, and rotation actually allows you to rotate the material in real time. And this works with the scaling and all that regardless of what scale you have set up. And if you have world align set up and you have, for example, two two separate meshes up against each other, you don't have to worry about there being any rotation seams because it will be world aligned. So if you go in close, you can see it's still displaced and all that. And then if I adjust the rotation, it's rotating all of the texture maps together. So your height, your diffuse, your roughness, ambient occlusion, all that stuff is moving together. So 0 would obviously be a 0 value. 0.125 would be 45 degrees. 0.25 would be 90 degrees. 0.5 would be 180, and then 1 would be 360, which would be the same as 0. So that's it. That is the way to set up an advanced tessellated displacement material and add in height fade, tessellation resolution fade, and rotation, as well as allowing you to change it to vertical or horizontal and flip the X and Y axis for the vertical or horizontal world space align. So if you have any questions, let me know.